Good afternoon, ma'am. Our topic is preemptive scheduling algorithms. Preemptive algorithms are scheduling algorithms that are used in operating systems. They allow the process to be interrupted or preempted before it finishes its execution, which gives other processes a chance to run. This approach helps ensure fair resource allocation and improves responsiveness. The preemptive algorithms we are going to show are round robin, shortest remaining time first, and priority scheduling. I'll hand it over to Ridhyansh.
Good morning, ma'am. My name is Ridhyansh and I'm from Group 1. So I'll be demonstrating the shortest remaining time first. And we have assigned the colors. We have taken 4 processes with the arrival time as 0, P1, P2, P3 and P4 with the burst times 3, 4, 2 and 5 seconds respectively. We have assigned various colors to each of them. So P1 is assigned blue color, P2 is assigned green color, P3 is assigned the white color and P4 is assigned the pink color. So what we are going to do is, during shortest remaining time first, the process with the smallest burst time executes first. So according to this, our P3 is going to be the first to get executed because it has the burst time of only 2 seconds. So as we can see that in the first time slot, the first second, as well as in the second second, the P2 gets executed. After that, we move on to the process with the second shortest burst time, which is going to be P1 with a burst time of 3 seconds. As we have assigned the color blue to it, we are going to add the color blue for the next 3 seconds of the time slots. So, considering that the burst time for this is 3 seconds, we added the blue color to the next 3 time slots. Then we take into consideration the next shortest burst time, which is going to be P2, and we have assigned the color green to it. So in the next 4 slots, in the next 4 slots, we are going to add the color green. So that is going to be the time at 6 seconds, 7 seconds, the 8-second time slot, and the 9-second time slot. And the last is the process P4, and we have assigned the pink color to it. And so the pink color is going to be filled in the last 5 slots, which is the burst time for process P4, which is 5 seconds. So this helps us to demonstrate shortest remaining time first. Thank you.
Hello everyone. My topic is SRTF and it is the preemptive version of SJF, shortest job first. And my numerical is that the arrival time of the 4 processes P1, P2, P3, P4 is 0, 1, 2, 3 and the burst time is 4, 2, 3 and 5. So according to the SRTF, we will see that P1 gets poured first because it's arriving at time 0. So we will pour it in the first slot. Next is P2 and the burst time for P2 is 2 and it's arriving at 1 second. So we will pour the next 2 slots as green. So it has got preempted here, and now we see that P1 gets poured thrice as it has there's a tie between P1 and P3. So we have to finish the process 1 first. Now we see that P3 gets poured 3 times because it has the burst time of 3. It's indicated by the white color. Next we have the last process, which is P4, and it has the burst time of 5. So all the other processes have been completed. So the next 5 slots will be of pink color. So SRTF has been completed.
Good morning. I will be presenting on the topic of preemptive priority scheduling using 4 processes. So we have taken P1, P2, P3, P4 with an arrival time of 0, 1, 2, 3 respectively. The priority for the 4 processes is 2, 1, 4, 3. and the burst time are 3, 4, 2 and 5. So starting with process P1, it will run twice and then it will be preempted out by process P3, which has the highest priority of 4 seconds. Highest priority of 4. It will run twice, followed by process P4, which has a burst time of 5 seconds. So we have these markers here in order to show the timestamp for each process and for how much powder we have to pour for every process. So P4 will run 5 times. After which P1, which was preempted out earlier, comes into the picture. And lastly, the process P2, which has the lowest priority, will run for last 4 seconds. So this was priority scheduling in preemptive algorithms. Now I will hand it over to Rishabh in order to demonstrate round robin scheduling.
Good evening, ma'am. I will be explaining round robin scheduling. In round robin scheduling, if we assign a fixed time quanta to each process, which we have taken as 1, and if the process burst time is not over, then it gets placed back into the queue. So I'll be starting. First, we add process 1 to the ready queue, and it goes to the waiting queue. It runs for 1 time second. After that, it goes back into. After that, process 2 comes. That runs for 1 second. Process 1 is placed back into the queue meanwhile, and so that comes into the running queue, and process 2 goes to the ready queue. At this time, process 3 has also arrived, so we put that into the ready queue. After that, process 2 comes. Process 2 is over, so now we don't add it back to the queue, and process 1 again comes in. After that, process 4. After that, process 3. Process 3 is now over, so that is not placed back into the ready queue. After that, process 2 comes. After that, process 4. Again, process 2. Now process 2 is over, and finally only process 4 is left, which runs for the remaining 3 time quantas. Thank you. With this, we have finished presenting our preemptive scheduling algorithms.